Chapter 6, Section 2, we're going to be solving systems using substitution. And if you can just think of what substitution is, it's just basically replacing one thing with something else that is equivalent to it. So the easiest example I have is think about if you have $1 and you replace that with 4 quarters. It's the same amount of money, they're both equal, but you're replacing it with something that kind of is in a different form. Okay. I guess you don't necessarily have to write this down, but basically what we're looking at is this is a way to solve linear systems of equality. Sorry, this is a way to solve linear systems. Okay, and basically what we're doing is we're solving for one of the variables, and then we use substitution to put it in the other equation. Okay, and so we will show you how that works right now. So this is a very basic one. This is already kind of set up nice and easy for us, but we have two equations there. We have y equals 3x, and we have x plus y equals negative 32. So what we can do is we already have one equation that is solved for a variable. So this is in terms of just y equals something. We can take this, and instead of having y here, we can replace it with what y equals, which is 3x. So now we can rewrite this as x plus 3x equals negative 32. And again, we're just replacing y with what y equals. Add those together, you get 4x equals negative 32. Solve for x, you get negative 8. So now that's what x is. Remember, we're looking for a solution for the system. And a solution comes in terms of an x and a y. So we now have the x, which is negative 8. We need the y. How do we get the y? Well, we plug x back into one of these equations. Either one of them works. This one's just going to be the easiest. So I took this equation and replaced the x with negative 8. And that gives us y equals negative 24. Now, to check this, to make sure that this works, you plug these two numbers in either equation. So if we plug it in this one, this one right here, replace x with negative 8. So this is our checking. And I replace the y with negative 24. Negative 8 plus negative 24 is negative 32. And what do you know? It's the same, so that means we did it right. Okay, let's try another one. So here we have, again, the equations are both in y equals, so you can take either one. It really honestly doesn't matter. How about I take this one and plug it into this one? So we are going to replace the y with what y equals. 2x plus 7 equals x minus 1. So again, replace this y with what y equals up here. Solve for x, so I'm going to subtract an x. That leaves me with 1x over here plus 7 equals negative 1. Subtract 7. I get x equals negative 8. Take negative 8 and plug it back in. The bottom one is the easiest. And I get y equals negative 9. So my solution is negative 8, negative 9. And remember, if we were graphing these, that's where the two lines would intersect. Check to see that I did it right. Plug them back in. How about the other one? So this is my check. We have negative 9 equals 2 times negative 8 plus 7. Negative 9 equals negative 16 plus 7. Negative 16 plus 7 is negative 9. It works. So we did that one right. What if one of the equations is not in terms of just one variable? Then you have to convert them. You have to basically solve for one of the variables. Now you can solve for either x or either y. It doesn't matter. In this case, y would be the easiest because we already are in terms of 1y. So what I'm going to do is I'm going to take this equation and I am going to get y all by itself. So I have y equals 2x plus, y equals 2x minus 3. Now y is by itself. So now we can replace that y up here with 2x minus 3 plus 4x, we keep whatever's left, equals 14. Distribute 6x minus 9 plus 4x equals 14. 6x plus 4x is 10x. Add 9. I get 10x equals, what do we got there, 23. And if I divide by 10, I get x equals 2.3. And then if you take x and you plug it into the equation that we didn't use, which was this, we take negative 2 times 2.3, and we get negative 4.6 plus y equals negative 3. Add 4.6 to both sides, and you get y equals 1.6. So our solution, therefore, is 2.3, 1.6. Now, right away, this doesn't feel like, we don't often get decimals. It doesn't feel like the right answer. We'll go ahead and check. Plug it back in and plug it into either equation. So I'm going to take the easier of the two, which is negative 2 times 2.3 plus 1.6 equals negative 3. Negative 2 times 2.3 is 4.6 plus 1.6. Negative 4.6 plus 1.6 equals negative 3. And if we take negative 4.6 plus 1.6, we get negative 3, which equals negative 3, which shows us that we did indeed do it correctly. So that is solving systems using substitution.